Okay, I just want to talk about the greatest integer function. And sometimes this can be a little tricky based upon its definition, but if you think about it a little bit, it will clear up. So this is the notation. Sometimes we use a little bracket like this. Sometimes we use intx on your calculator. And y is defined as the greatest integer. So y will be an integer that's less than or equal to x, whatever is in here. All right? So if we take a look at it, let's just kind of get an idea of how this kind of works. So if we look over here, let's say 1/2. When x is 1/2, what's the largest integer that's less than 1/2? Well, the integers that are less than 1/2 are all the integers that are to the left of 1/2. So -6, -5, -4. These are all less than 1/2. What's the largest one? 0. If I look over here at 0, what's the largest integer that's less than or equal to 0? Well, these are all integers that are less than or equal to 0, but this is the largest one, 0, because it can be equal to 0. Let's look at 1. What's the largest integer that's less than or equal to 1? Well, what's the largest integer that's to the left of 1 or equal to 1? 1. 1 and 1/2, it's again always to 1. All these numbers less than or equal to 1 and 1/2. All the integers that are to the left of 1 and 1/2 would be all these, and the largest one would be 1. So you can think of it like that. That's maybe a little bit easier. And we can go backwards. Let's say -1/2. What are the integers that are less than -1/2? Well, all these, -6, -5, -4, -3, -2, -1. What's the largest one that's less than or equal to -1/2? -1. So that means it's this value here. So that's the y value, the vertical position. So if you think about that, it might make it a little bit easier to graph. Now, if we set up a table of values, it's just not one value. It gives us one value. It's an interval. So between 0 and 1, the value of intx is going to be 0. From 1 to 2, it's going to be 1. From 2 to 3, it's going to be 2. And from 3 to 4, it's going to be 3. So you can see that. All right? Oh, sorry. So you can see this over here. It's the greatest integer. And you can look up at your graph and get that just by thinking about it. Now, let's take a look at a little more complicated problem and how would we deal with this. And there's a couple ways to deal with it. One requires a little bit more intuition than the other, so I'll give you a more procedural way to do this. It'll give you a little bit of time to grow into the intuitive idea. And this is what we want to graph. Y equals 3 times int 2x minus 1. Now, if we took this and we put this in our basic form, I could take the 2 and I could put it out in front. Remember, we want 1 in front of the x always. So if I take that out, I have 2 times x minus 1/2. If I multiply this out, I get 2x minus 1, so that checks out. Now, that means I have got a horizontal shift of -1. This is inside, so this means I've got a horizontal compression of 2. This means it's compressed by a factor of 2, which means it will be 1/2 as long. And this is a vertical stretch of 3, so the vertical distances will, instead of being 1 like they are on our normal graph, you can see on our normal graph they're going to be 1. In this case, they're going to be 3. So you can deal with it like this, but it can be a little bit challenging. So here's what I did. I take a look at my basic inside the intx, and I know that if I look at my basic, whenever that's 0, that's going to be the interval from 0 to 1. So I want to find the interval that corresponds to that. So what's going to make this 0, which will be the left endpoint? So I just set this equal to 0. Add 1, divide by 2, I get x equals 1/2. So that's going to be my left boundary, my left endpoint. And then what's going to make this 1? So I set this equal to 1. I add 1, I get 2. I divide by 2, I get 1. So it's going to be 1. So that means the interval from 1/2 to 1 will make this 0. So it's going to be 0 in this interval from 1/2 to 1. Because 1/2 is the value that makes this 0. And 1 is the value that makes this 1. Okay, then what's the value that makes it 2? Because I know that this is going to be my left endpoint. So what value will make this 2? So if I put 2 in here, set it equal to 2, add 1, I get 3, divide by 2, I get 3/2, I get 1 and 1/2. So I see my interval is going to be like this. So this is just the inside part. So you can see the pattern. So it's by 1/2, and well, that is a compression of, that's a horizontal compression of a factor 2 because it's making it half. So you have to kind of invert that. That's where the intuitiveness comes in. And then the next one, what do you think would be the next interval? What is going to be 1/2 to 2, 2 to 1/2, and we're going to have these same patterns. Now I'm multiplying this by 3. It's just not the function, so I'm multiplying every vertical value by 3. So 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. So now I actually have my vertical values, and these are my intervals. So I go to graph it. It's going to be 0 between 1/2 and 1. It's going to be 3 from 1 to 1 and 1/2. It's going to be 6. So I have to go over here. So it's going to be 0. I have to look back and forth. So I have to look back and forth. So it's going to be 0 from 1 and 1/2 to 1. I'm sorry. It's going to be 0 from 1/2 to 1. Then it's going to be 1 from 1 to 1 and 1/2. But I have to multiply that by 3. So it's going to be 3 from 1 to 1 and 1/2. Then it's going to be 6 from 1 and 1/2 to 2. All right. I can go backwards. I can just follow the pattern backwards. So this is just going to shift over 1. So it's going to be from 0 to 1/2. It's going to be -3. And then from -1/2 to 0 is going to be -6. And see, it kind of follows that pattern. So it's a step function. But once you see the trend, all you actually need are 2 steps, and you can just project everything else. Okay. So that's kind of the technique. So kind of review that, then you can try this on any of these. This is, like I say, the more intuitive approach, but I think you really have to kind of have a backup. Now, another backup is your calculator, so I kind of cheated. So let's put this in the calculator and see if we get what we got. So I get out my trusty calculator, and I want to graph this. So I'm going to have to use that math function. So I turn the thing on and go y equals. And it's going to be 3 times. So I hit 3. 3 times, and then I've got to go to math. And then number over here, so just arrow to the right, number. And down here, number 5, you see int. That's our integer, so you hit 5. And then you put 2x minus 1 in there. 2x minus 1, parentheses. And then you graph it. Now, I wanted to kind of see what's going on over here, and I got a kind of a high range, but not very much of a domain. So I set my window for x going to go to -2 to 3, but y goes to -10 to +10, so I can get the 6 in anyway. So and actually a 9. So then we graph it, and there you go. You can see your steps. Now these are 3 units, and this is 1 unit. So this is going to be my, and you can't see the part over here because this is on there. So this is going to be the 1/2 to 1. And this is 3 units, so this is going to be the 1 to 1 and 1/2 at 3. And you count these 1, 2, 3, 4, 5, 6 units over here. And then you can see the other ones down over here. This is -3, it's going to be 0 to 1/2. And this is going to be the -6, it's going to be -1/2 to 0. So you can check that out. So you can always use your graphing calculator to check your work. And then once you think about these, then you can start to, rather than do a little technique like this, which is just, something I came up with, rather than do something like this to set your intervals, then you can start to look at the function and you can say, well, yeah, I've got a shift of -1/2 to the left. So usually my 0 is here, right? It's normally like this. Dot open. So that dot is shifting 1/2 to the right. Let me see this over here. So that dot is shifting 1/2 to the right. And instead of being 1 unit long, because it's got a horizontal compression of factor 2, you have to realize that that's going to make it 1/2 as long. And then you've got, the next one's going to be, instead of going up 1, you're going to go up 3. then you can kind of work it out from there. But that, you just have to think about that a little bit before you acquire that ability to use these dilations, compressions, and horizontal shifts on a function like this. That's a real challenge, or I would say a stretch. So, but you can grow into that. But I think this is a good way to kind of double check and then go back and see how that works. Okay, I hope that helps.